Hey kiddos, welcome to week number 5 of virtual learning. You just took a quiz on Newton's universal law of gravitation, gravitational fields, and how they're applied using Kepler's third law of planetary motion. Okay, so remember, gravity is a field, right? It creates a field that describes how a mass can act on another mass without touching it. Okay. Another thing that we can describe using fields is electric charge, okay, or static electricity. You've seen that. Maybe you've walked in socks across a fluffy carpet and touched a metal doorknob and felt a shock, or rubbed a balloon on your head and then separated them. And you could see your hairs sticking up when the balloon was nearby. That process of transferring electric charge through rubbing is called charging by friction. If we were in the classroom, we'd do an investigation to see what materials charge best through friction. It turns out that things like plastic, sometimes glass, but things that are considered electric insulators charge best by friction. Okay, so I'll define the term electric insulator later on in the lesson, but I want to do a little demo. Okay, so what I've got here is a black plastic wand. This type of plastic is called ebonite, right, because it's black. Okay, I kind of like to think of it as a wand. And then I also have this fluffy purple fur. If we were in my classroom and we were doing the investigation, I have a whole bin of furs. Years and years ago, when Miss Watkins was still teaching IB physics, she had a student whose parent was a fur trader, and he had like samples. And so I have a bunch of like real animal furs that I use in the classroom to kind of test out static electricity charge. So just like you can take your socks and rub it up against the carpet on the floor, or a balloon and rub it up against your hair, we're going to rub a plastic thing with a furry thing, and we're going to try and charge up the wand. Okay, so again, this is called charging by friction. And furs work really well because things that have hair or fibers have a lot of surface area. And what we're doing is we're physically rubbing electrons from one surface to another. And so after you're done rubbing these, both objects should have an electrical charge, either positive or negative. Okay. Now, how do we test if something is charged? We use a device called an electroscope, and I've got a couple here that I want to show you. The first one is called a Pith ball electroscope. If I bring this back here, it's a black kind of hook stand, and then this thing that is dangling on the end, that's a pith ball. I'll get a little closer. Right, it's hard to see, but that's just a tiny piece of styrofoam. You know, if you get like a new electronic device, and it's coated in styrofoam blocks, right? If you accidentally break one of those blocks, the little tiny styrofoam pith balls go everywhere. Okay, so that's what we're doing. We're using an annoying little styrofoam pith ball on a string. Okay, this pith ball is electrically neutral, and so I'm going to try and test if I've gotten enough electric charge on this to impact its motion. Did you see that? That wasn't my breath moving it. Okay, I saw the pith ball was attracted to the wand. Okay, and then it touched the wand. So some of the charge was transferred between the wand and the pith ball. So now they have the same charge. Okay, they touched, and then it's not really working. Let's make this neutral again. Okay. So in class, we'd be making observations about what we're seeing. So charging the wand by friction, I made sure that the pith ball was neutral, had a neutral charge equal positive and negative just by touching it. Okay, it's a process called grounding. Oh, now it's attracted. I might need to try this again. Okay, I attracted. Oh, no, I did. It attracted. And then after it touched and stuck and had time to transfer charge, look, do you see that now? Now the pith ball is not sticking to the wand. It's repelled by the wand. Interesting. So initially it's attracted, and after they touch, the pith ball is repelled. Okay. So that's something that I would like you to write in your notes. Just an observation of what we did today. Again, we charged by friction, transferring some charge from the wand, or from the fur to the wand, charged by friction. Once the wand is charged up, it was able to attract a neutral pith ball, a neutral object. Okay. When the pith ball was attracted, it touched the wand. Okay. And then after touching, the pith ball and the wand, the wand now repelled the pith ball instead of attracted it. Okay, so I'd like you to record that in your notes for use to debrief what we saw last class, or what we saw this class. Okay, so now I'm going to neutralize the wand, okay, just by touching it with my hand. I've got another type of electroscope, and I'm going to ask you to do, once I show you this, I'm going to ask you to do a little bit of investigation with a virtual electroscope. So again, we've got a pith ball electroscope, and this one is called a foil electroscope. I'm going to try and get it so that you can see it clearly right here. Okay, so what this electroscope is it's just a jar. Okay, it's a jar that has a lid on it. Okay, and attached to this lid is a metal sphere, okay, that's attached to a metal post, right, that goes through the lid, and then there's a clear stopper with a hole in it. At the end of the metal post are these two really light metal foils. Okay, these foils are very light, right? If I blow on them, they'll move around. Okay, and let me show you. There are two of them here on the end. Okay, there are two of them, and they can move around. Okay, the purpose of the jar is to keep those foils insulated from other charges. Let's see what's the best place for these guys. Okay. All right, so let's try that. Now what I'm going to do, you can probably see back there my power supply that I took from school when I was allowed to go back in so that I could do these demos. All right, I'm going to charge this by friction. It's a sunny day outside right now, and that's really good because there are more free ions in the air, and we'll get typically a more dramatic result. Just watch, we won't see anything after I said that. All right, so we're charging by friction. Okay, and what I'm going to do is I'm going to get this wand near the metal sphere. Nothing happens. See, I told you, I jinxed it. All right, let's keep trying. Charge it up. Come on, little fur. Let's charge up the wand. Feels kind of staticky. All right, let's try this again. Get the wand near the sphere. We broke it. Sometimes they kind of get stuck on each other. All right. We'll give it one more shot and see how it goes. Okay. All right, so we're gonna charge this wand by friction and get it near this electroscope. I really want to show you what this does because this is the thing that you're going to use a simulation to manipulate. There we go. Did you see that? Did you see that move? Looking at the little foils down below here. Right, I get it near the wand or near the orb, and those little foils move apart. Now, why do they move apart and then go close together when the wand moves away? Okay, now what happens if they touch? They stay apart, right? If I touch the sphere, those foils go apart, and they mostly stay apart. They don't go all the way back together, okay? And my question is why? All right, so I'm going to ask you to do an electroscope simulation. There are instructions on the Google Classroom and a link to the simulation, and I'm going to ask you to take really careful notes, and we'll debrief what we saw next class. All right, kiddos? Have a good week.